through. Love life's the old way. It's like you're always stuck in second gear.
Hi everyone, today we're going to look at exponent laws. So the first law is the multiplication of powers. So if we have 4 to the exponent 3, and that multiplies 4 to the exponent 2, you could think of that as being the following. Remember, 4 to the 3 means 4 times 4 times 4 3 times. And 4 to the 2 would be 4 times 4 2 times. So if you look at that, you've actually got 1, 2, 3, 4, 5 multiplications of the number 4. Okay, and we know how to write that. That's really 4 to the exponent 5. Well, if you look at this, what's interesting is all of this is 4 to the exponent 5, and it works out that 3 plus 2 is 5. So you can actually add up the 3 and the 2 and generate the overall exponent, in this case, which is 5. So what we would say if we were asked to do a question like this, we would have 4 to the 3 and 4 to the 2. Okay? Because you're multiplying powers, you can literally take these two exponents and you add them up. And the answer becomes 4 to the exponent 5. And you can grab your calculator. So your calculator tells you 4 exponent 5, and you end up seeing that it's 1,024. Let's try another one. What if we had 3 to the exponent 6 and 3 to the exponent 2? Well, if we remember our rule, all we have to do is say this is the same thing as 3 to the exponent 6 plus 2, which is 8. So it's 3 to the 8. And you grab your calculator. 3 exponent 8, 6,561. So here's the general rule for this. If you have some base, call it x to the exponent m, and you have another base x, but his exponent's different, call it n, the rule for multiplication of powers is you would do this. The overall answer is x to the exponent. You have to add m and n. Just like over here, m would have been 6, n would have been 2. We added them, and we got 8. Okay, so there's the general rule. There's another rule called the division of powers. And division means to divide. So we could have 5 to the power 6, 5 to the exponent 6, divided by 5 to the exponent 3. Or another way to have that is we could write it like this. 5 to the exponent 6 divided by 5 to the exponent 3. Okay? And that can be thought of as the following. Okay? This means 5 is repeated 6 times as multiplication. So 5 times 5, got to do it 6 times. Okay, one more. 1, 2, 3, 4, 5, 6. Okay, and now we divide that by 5 to the 3. And I hope you see here, this is a lot of writing. Okay, and what happens now is when you divide, you can actually cancel from top to bottom. So I can cancel you with you, you with you, you with you, and now there's no more on the bottom to cancel with, so you're left with these 3 on top. There are 3 5s. Okay, so that is actually 5 to the exponent 3. That was a lot of writing. What if there was also another rule? And I'm sure you've guessed it, there is. Watch this. Okay, 5 to the exponent 6 divided by 5 to the exponent 3. All you need to do is subtract the exponents. 6 take away 3 gives 3. Okay, or 6 subtract 3, you're left with 3. It always works. Let's try another example. What if we had 5 to the exponent 8 divided by 5 to the exponent 4? You're not going to write this all out anymore. All you're going to do is say 8 subtract 4. Well, that's 4. And the answer is 5 to the exponent 4. And just like before, you can evaluate that with a calculator. 5 to the exponent 4. You end up with 625. So here's the rule for division of powers. All right, so it looks just like the other one for multiplication. If you have some base x with an exponent m, and you divide that by some base x, the exponent n, all you have to do is subtract these two exponents. X to the power, excuse me, x to the exponent, m subtract n. And you see that works. Look over here. We subtracted 6 and 3. M would be 6, n would be 3, and the overall result is 3. Over here, m would be 8, n would be 4. You subtract them, and it becomes 4. Okay, and then you can evaluate it. Here's another rule called the power of a product. Let's say you have x to the exponent 3, and all of that is to the exponent 2. Okay, we know that that would look like this. So I have x multiplying itself 3 times. Okay, and then after that, it has to multiply itself again because it happens twice. So x times x times x is just this, and then it multiplies itself, 1, 2, 3. Okay, so what do we have? We've actually got, really that's just like x times x times x times x times x 6 times, and that's a whole lot of writing. Okay, we would actually short form that as x to the exponent 6, because we count 6 x's, so it's to the exponent 6. There's got to be a faster way though, and there is. If you look at the original question, okay, the better method is the following. X to the exponent 3, then another exponent 2. All you need to do is look at these two exponents and you multiply them. What's 3 times 2? Well, it's 6. Okay? So all you need to do is multiply these two exponents and you get x to the 6. Let's try another one. What if we had m as a base to the exponent 4, then to the exponent 6? I don't want to have to write all that out. I'd rather use the rule. Okay, so you look at these two exponents and you multiply them. 4 times 6, that's 24. And the overall answer is m to the 24. You can even do this with numbers. Try this other example. 2 to the exponent 4 to the exponent 3. All right, well, let's use our rule. You take these two exponents and you multiply them. So that's 2. Well, now it's to the 12, because 4 times 3 is 12. And that, being a number, can go in your calculator. 2 to the 12. Oops, wrong punch there. Try that again. 2 exponent 12, 4,096. Okay? And as a rule, if ever you have x to the m to the n, the overall answer is x is at the exponent m who multiplies n. This means they multiply each other. So that's your general rule. Let's look at one last rule for today. So we have the power of a quotient. Okay, quotient means when there's fractions. Okay, fractions are like types of divisions. Okay, so the way this is going to work is the following. You've got a fraction here, and the numerator is a power. So is the denominator. Here's what you're going to do. You don't want to have to write all this out. We want to use these new rules. Okay? When you end up having a quotient, so this entire thing is a fraction or a quotient, you just have to do the following. It's sort of like the power of a power. This 5 will need to come and multiply 2. And it'll also have to come down here and multiply 3. So the overall result changes to this. It's not 3 to the 2 anymore. It's whatever 2 times 5 is, which happens to be 10. Okay, it was 3 stays as your base. 2 times 5, you end up with 10 here. And the same thing goes for the denominator. You keep your denominator's base, the 4, and then you do 3 times 5, which is 15. Okay? And you end up with a more simplified version. All right? And actually, you can put these numbers in your calculator and see what you get. So 3 to the exponent 10 is 59049. And then 4 to the 15 is a really big number. Okay. So here we go. 107,374,1824. Okay? And that's just a big fractional answer that we will not reduce. We won't actually do the division. We'll just leave it like that for now. So that's it for today. Check in with your teacher for the worksheet you need to do with this, and then obviously there'll be a check to demonstrate you are capable of doing this type of these types of questions. Talk soon.
No one told you life was gonna be this way. The job's a joke, you broke, your love life's the old way. It's like you're always stuck in second gear.